Hello everyone, welcome to Exam Essentials. This is Fahim and today we'll be solving this paper from Chemistry IGCSE. So without wasting any more time, let's just get into it. Okay, question 1. It says that the question is about elements, compounds and mixtures, okay? Now the box gives the name of some of the substances such as this and this and this, okay? Now choose a substance from the box to answer each of these questions. Now, give the name of a compound. So what basically is a compound? It comprises of elements, right? It comprises of two or more elements that are binded together in a fixed ratio, you could say. So for an instance, in this scenario, H2O is going to be the compound because it comprises of two elements, hydrogen, oxygen. And see, they have a specific ratio, 2:1, which implies that there are two hydrogen for one oxygen. This is what we refer to as something being a compound. Now, most of the time, students would say that either they should be writing it in this type of words or in this type of symbols. I mean, basically, by the end of the day, this is in literature that you have to write everything in words, right? You are a chemistry student, hence these symbols are perfectly fine. Now, give the name of a mixture. Okay, it comprises of elements that are not chemically bonded together. Okay, unlike these compounds, in compounds they are chemically bonded, but in mixture it comprises of different substances and so on. So in this example, petrol is going to be the mixture. Now, what is a diatomic molecule? Di, it means two, right? So fluorine, chlorine, bromine, iodine, these are all diatomic molecules. In this case, this is going to be our diatomic molecule. Now give the name of a metal element, right? So the name of a metal element is gonna be calcium, sodium, lithium, potassium, is what we refer to as being something that is a metal, okay? So yeah, calcium. Moving on to the next question. Name the technique used to separate crude oil into fractions, fractional distillation. Okay. Now give one use of kerosene fraction. Okay, so basically, the kerosene over there is used for aircraft fuel, right? Is used for aircraft or jet fuel or aviation fuel or aeroplane fuel. Anything works. I went with aeroplane fuel. Moving on. Magnesium reacts with dilute HCl to form magnesium chloride and hydrogen. Okay. Now, this is an example of an acid-base reaction, or in other words, this is an example of a neutralization reaction. And all of the neutralization reactions are exothermic reactions, which means that when the reaction occurs or when the reaction progresses, it releases up heat to the surrounding, okay? Now, during this reaction, hydrogen gas would be produced that would be collected in this syringe over here, and basically we could find the volume of hydrogen gas produced. Using this syringe. So the reaction is exothermic and magnesium is in excess. Okay. Now, what do you mean by something that is exothermic? As I said, heat is lost to the surrounding, or heat is given out or released to the surrounding. Now, this thing energy, this isn't really mandatory. You could say that's completely fine, and you could even say heat is released to the surrounding or lost to the surrounding. It doesn't really matter. Now complete the chemical equation. So this plus this would lead to the formation of MgCl2 plus hydrogen, and you have to make sure that the equation is balanced as well. So yeah, now draw the sketch draw a sketch graph to show how the volume of hydrogen chloride hydrogen changes with time, right? So as the reaction progresses, this and this leads to the formation of hydrogen, which means that the volume of hydrogen is going to increase. The volume of hydrogen is going to increase, and then it is going to be this in this curvature form. Now, why basically is this curvature form? Because this and this is reacting together to form this hydrogen. Now, this thing is in excess, but whenever all of the HCl gets used up, the magnesium will react with who? There is nothing for magnesium to react with, right? And as there is nothing for magnesium to react with, the volume of H2 would remain the same. It would not increase or it would not decrease because all of the HCl has been used up. So the curve would look something like this. So yeah, moving on. Explain why increasing the temperature of hydrochloric acid affects the rate of reaction. Okay, this is a very common question. And by this point of time, you should be having this memorized. Okay, because this is one of the VVIP question, very, very important question. VVIQ, sorry, not P. Very, very important question, not VVIP. Sorry for that. This is because when you increase the temperature, the rate increases obviously. Why does the rate increases? Because the kinetic energy of the particle increases and hence frequency of collision increases. Okay, frequency of collision increases or there are more collisions in a given period of time. And also as you increase the temperature, more particles have the minimum activation energy needed to react. One of the most common question. This is what I have said so far. Make sure that you have these points memorized as these points are based as part the maximum points. And obviously you may expect to encounter a question similar to this. Because this is, as I said, this is one of the most common question. Now, enthalpy profile diagram showing delta H and activation energy, reactants and product. Okay. Exothermic energy profile diagram. So this is not going to be an energy level diagram like this. Okay. So this is going to be an energy profile diagram. And this is going to be for what? This is going to be for an, okay. So this is going to be for an exothermic reaction, which means that delta H should be pointing downwards. So if we do it, it would look something like this. This to this is our activation energy. You have your reactants, you have your products in the below part, and this is delta H. Now, for an endothermic reaction, which means that heat goes into something, the delta H would look something like this, del H. So yeah, that brings us to the end of question 2. Moving on to question number 3. Just a moment.
Let me guess. You are watching videos, taking notes, maybe even grinding late at night. But the marks, they are just not going up. You are stuck, and it's frustrating. But here is the truth, it's not your fault, it's the method. And that's exactly where Exam Essentials makes the difference. We at Exam Essentials actually offer two very powerful courses to navigate you towards success. The first one is the most popular high impact crash course. If you are just 4 to 6 months away from your exam, this course is going to be a lifesaver for you. And the second course that we at Exam Essentials actually offer is the complete 1 year course. This is basically for the students who want full support from day one to exam day. And the best part, our students' results speak for themselves. Both the courses are actually open ahead of every exam session. No matter whether you are going to give your exam for the May 26, Jan 27, May 25, or October 25, doesn't matter. We always offer these two courses before every upcoming exam session. To join or know more, just check the description box below. You will find our WhatsApp number and Facebook page link right there. Let's turn your effort into results together.
Okay, this question is about group 2 elements and their compounds. A sample of magnesium contains 3 isotopes. Okay. Atoms of the same element that have the same number of protons but different number of neutrons. This is the definition of isotopes. Calculate the relative atomic mass of this magnesium. So how do you do it? So this is again one of the most common question. So for this, you basically need to remember something. That is AR equal to mass 1 times abundance 1, mass 2 times abundance 2, mass 3 times abundance 3 divided by the total abundance. And this should be equivalent to the AR of magnesium, which means the molecular mass of magnesium. And if you do it, wait, no. So basically, you do not need to do that. Ignore my comment. Just mass 1 times AR equals to M1 times abundance 1, M2 times abundance 2, M2 times abundance 3 divided by abundance 1 plus abundance 2 plus abundance 3. And that basically would give you the AR of this magnesium. See, that's just what I have done over here so far. Now, these are the mass, these are the abundance. M1 abundance 1, M2 abundance 2, M3 abundance 3, and you plus all of these abundance together. So yeah, which of this compound is insoluble? Which of this compound is an insoluble solid? Okay, so soluble. All of the nitrates are soluble. Calcium sulfur. This is not fully soluble. Okay, so yeah, this is an insoluble solid. Now you need to know the solubility chart. Okay, you could find this in your book. And if you still cannot find that in your book, then do let me know in the comment section below. Moving on. Um, Magnesium oxide is an ionic compound. The diagram shows the atoms of magnesium and oxygen. Okay. Draw the diagram to show the structure of each ion in magnesium oxide. Each ion. Okay. Each ion. So magnesium is going to lose the 2 electrons, and the 2 electrons will be gained by this 2 oxygen. Now we have 1 oxygen over here. We need another oxygen as well. Okay. So yeah, just a moment. Oh, wait. Just a moment. 1, 2, 3, 4, 5, 6, 7. Okay, sorry. So there are 2 electrons in the outer shell, which is going to be gained by the oxygen, right? And as magnesium loses this 2 electron, it would lead to the formation of Mg2 plus. And as oxygen gain the negative charges, it would lead to the formation of 2 minus. Okay. So yeah. Moving on. Uh, the table lists some substances and shows which substances can conduct electricity. Water, no. Sodium chloride, solid, no. Aqueous, yes. Okay. Explain these observations, refer to the structure and bonding in your answer. So water is a simple covalent compound. It do not have any charged particles or delocalized ions that could conduct electricity. Okay? As it does not have any free electrons or delocalized electrons or mobile electrons, they cannot move and hence cannot conduct electricity. For magnesium chloride, solid one, it is a giant ionic compound and ions over here cannot move. Hence, it can also not conduct electricity. But on the other hand, in this aqueous magnesium chloride, the ions are mobile. The ions are free to move. And as they are free to move, they can conduct electricity. One of the most common question as well. So yeah, that's just what I have written over here. Just take a reading at it. Moving on. A concentrated solution of magnesium chloride is electrolyzed. The chlorine forms as the positive electrode, right? So Cl minus. This is an anion, right? Anion would be going to the what? Positive electrode, that is anode. Wait. Yeah, this is basically anion, right? Now, anion would be going to the positive electron. That is what? Anode, right? Anion would be going to the positive electron, right? Just a moment. I feel like something I'm messing up something with A2 chemistry. Just a moment, everyone. Um, just a second. Uh, okay. So yeah, cation would go to the cathode, so negative, and anion would go to the anode. Okay, yeah, sorry for that. So basically, there is this chapter from A2 chemistry known as electrochemical cells, and I was doing this last day with my students, so I was kind of messing it up, right? Because that electrochemical cell is the reverse of this electrolysis. So anion would go to anode, that is the positive electron, right? And the anion would be basically losing up the electron to the positive electron. Okay, so yeah, the half equation for this would look something like this: Cl2 plus 2e minus. Now over here you have two negative, and over here you have one negative, so you're going to basically balance this charge out as well. Okay, so yeah, give a reason why this reaction is classified as an oxidation reaction. Why? Because electron is being lost, and the loss of electron is what we refer to as oxidation reaction. Now chloride is losing the electrons, and the loss of electron is what we refer to as oxidation. Okay, so yeah, this question is about ethanol and ethanoic acid. Okay, ethanol reacts with potassium dichromate 6 to form ethanoic acid. Name other reagent used in the reaction. So sulfuric acid or phosphoric acid. Now you could say concentration or dilute, doesn't really matter. Just go with sulfuric acid or phosphoric. I would go with sulfuric acid. Okay. Now color change as this reaction occurs. Cr as this reaction occurs, it leads to the formation of Cr3 plus, that is green in color. So the color changes from orange to green. You should be having this memorized. Okay. Moving on. Ethanoic acid reacts with uh, sodium carbonate. Complete the reaction. Do not get afraid by looking at this. This is basically an acid plus carbonate reaction. So it would lead to the formation of salt plus carbon dioxide plus water. Now for the formation of salt, you have to know this. This should be the equation for the salt, not something like this. This should look something like this, okay? So yeah, salt, carbon dioxide, water. State two observation in the reaction. First of all, bubbles of a colorless gas would be formed, and um, this thing is that the solid sodium carbonate, this one would start to disappear. Okay, so yeah. So yeah, it starts to disappear, and the bubbles of a colorless gas forms. That is this. Okay. A student prepares ester ethyl ethanoate by reacting ethanol with ethanoic acid. Okay. And the student's method is this: mix equal amounts of ethanol and ethanoic acid in a boiling tube, add a few drops of concentrated sulfuric acid, place the boiling tube in a hot water for several times, okay? For several minutes. Now, this thing is basically acting as a catalyst. So, what? State the role of catalyst. Speeds up the chemical reaction, okay? Acts as a catalyst to speed up the chemical reaction. Now, instead of directly heating the boiling tube, they're inserting this boiling tube in a beaker of water and heating it. Okay, now why is this? Because there's just that's what the next question is about. So basically, ethanol is flammable, and if you directly heat the ethanol, then there's a chance of an ignition. Okay, so yeah, uh, that's just what I have written. State the how the student would know that the ester has been formed. So because there is going to be a fruity smell. Display formula of ethyl ethanoate. Okay, so yeah, let's just see. I have drawn the basic structure. This is our acid. Sorry, this is our alcohol. This is our acid. Okay, so the acid is going to lose the OH and the alcohol is going to lose the H, and it would lead to the formation of this. And this is our ester bond or ester functional group, and that's basically the displayed formula of it. Okay, so yeah, just a moment, everyone. Moving on. This question says that the student carries out a titration to find the concentration of a solution of sulfuric acid. Okay. So you basically use the method of titration to figure out the concentration of something that is unknown. Fill a burette with sulfuric acid and record the reading. Transfer this of potassium hydroxide to a conical flask. You add an indicator. You place the conical flask on a white tile. You swirl the flask continuously while adding the sulfuric acid. Keep adding the sulfuric acid until the endpoint has been reached, because near the endpoint there is going to be a color change due to this indicator. Now, yeah, okay. So keep adding sulfur until record the rough reading at the endpoint. Okay, we record the reading of the burette at the endpoint to figure out the wait to figure out the volume of acid needed to react with this potassium hydroxide. Now, just see something, right? 25.0. When you see this something given in decimal, it would mean that you're using a pipette. I repeat, whenever you see something that has a decimal like this, it basically means the use of a pipette. Name the most suitable piece of apparatus. See, pipette. State why the student places the conical flux on a white tile to basically see the color change more clearly. The diagram shows the reading of it. Okay. the initial reading is given in the table. Complete the table giving both the values to it. Okay. So initial reading is given. The volume of acid added is gonna be the uh now the volume of acid added is gonna be final minus initial reading. Okay. Cause cause as the beer rate goes down, the volume increases, right? So final minus initial uh volume would give you final minus initial would give you the volume of sulfuric acid that was added. Okay. So yeah, the final volume would look like 31, 32.2, 3, 4, 5, 6, 7, 8, 9, 32.1, 32.2, something around 32.23 or something like that, right? So yeah, 32.2, as I said, or 23, and so on, right? So this minus this would give you the volume of sulfuric acid that was added. Now, the student repeats the titration more accurately 4 times. The table shows, okay. Now, it places a tick on the concordate result, and the concordate results are the one that differs by 0.20. So these three are going to be my concordant results. To calculate, now you use these results to calculate the mean. So this plus this divided by 3. Moving on. Now, it says that another student also used titration. The student uses this of the base with the concentration of this sodium hydroxide. So with the concentration of this, and the mean volume for the sulfuric acid was this. Okay. Okay, I understood. Now this is okay. You find the moles of it. Once you have the moles of it, you find the moles of this as well. And moles of something in solution is gonna be, you have the volume of the acid, you know the moles of it. Now you find the concentration by dividing by the number of volumes, number of moles divided by volume. Okay. So yeah. So for the number of moles of this is going to be volume times concentration. Now you have to ensure that the concentration is in, you have to ensure that the volume is in dm cube. So what you're going to do is you're going to divide this thing by 1000. It will look something like this, right? Since this is in a ratio of 2:1, the moles of H2SO4 is gonna be what? The moles of H2SO4 is gonna be the moles of potassium hydroxide divided by 2. Because this is basically in a ratio of 2:1. If you are unsure that how am I deducing these ratios and so on, you could check our videos on chemistry P1, where I have explained these things in great details. Okay, so yeah, moving on. This should how the working should be like. Moving on. So the next question says that the student repeats the titration without the indicator. Okay, they added exactly this of the acid to potassium hydroxide to the base. Describe how the student could obtain pure dry crystal of uh, potassium potassium sulfate crystals. Okay, from the reaction mixture. Okay, so first of all, um, you have to describe the procedure, right, to obtain that pure salt. So how you're gonna do it? So you basically heat the solution containing this to the crystallization point or until it has become saturated and so on. Okay. And then what we are going to do is we are going to cool the solution so that the crystals starts to form. So the solution could crystallize, or you could say in other words, we then filter out the crystal forms. We filter out the crystals with our filter paper or something, and we leave the crystals to dry. So yeah. Now you could dry the filter paper, you could dry the crystals on a filter paper, or you could use an oven for that. But I would basically go with drying in a filter over the filter paper. So yeah, that's just what I have written over here. Moving on to the next question. Hydrogen reacts with iodine vapor to form this. Okay. This plus this leads to the formation of this. Okay. Now del H, right? Delta H represents the this value represents what the forward reaction is. Always remember this value represents what the forward reaction is. It means that as this is a positive delta H value, enthalpy value, it means that the forward reaction is what? Endothermic. If the forward reaction is endothermic, then the backward reaction is obviously going to be exothermic. Okay. So test for hydrogen, common. Insert a lighted spleen. A pop-up sound is heard. Insert a lighted spleen. Now state what is meant by this symbol. Reversible. In a sealed container at equilibrium, the condition were at these and these. Okay. All right, understood. The temperature of the reaction is increased, but the pressure is kept constant on the yield. Okay. So as we know that the forward reaction is endothermic, so if you increase the temperature, the equilibrium would shift to the right. Why? Because the forward reaction is endothermic. Because if you increase the temperature, the equilibrium would shift to the position that is endothermic. And if you decrease the temperature, the equilibrium would shift to the position that is exothermic. So yeah. Okay, moving on. The pressure of the reaction mixture is decreased to 1 atm, but the temperature is kept constant. Okay. So effect. So if you decrease the pressure, equilibrium shifts to the position that has more moles of gas. And if you increase the temperature, equilibrium shifts to the position that has fewer moles of gas. Since the moles of gas on either side of the equation is the same, so the decrease in pressure or the increase in pressure is not going to have any effect. Okay, so yeah. Moving on to the last question. It says that an excess of this reacts with this of iodine. At equilibrium, the yield of hydrogen iodide is 80%. Calculate the volume of hydrogen iodide produced at room temperature, giving your answer in the standard form. Okay, the molar volume is given. Okay, now you have the moles of it, right? Sorry, you have the mass of it. What you could do is you could find the moles of this as well. Moles of this iodine. If you have the moles of it, it reacts with this in a 1:2 ratio, which means that whatever the mole of iodine is, the mole of this is going to be 2 times that the moles of X, right? And you have to make sure that while you figure out that moles, you have to do 80% of that moles as well. 80% of the moles, right? Because in the question it says that 80% of this forms, right? And if you have the moles of it, what you could do is uh, moles of HI is going to be volume by molar volume, because that is a gaseous reactant. You have the moles, you have the molar volume, that is 24,000. So you could easily figure out the volume of that HI. So yeah, that's just what I have done over here. Let's just take a look at it. Moles of this is going to be 2 times the moles of this times 80%, right? Because it says that the equilibrium yield is 80%, okay, not 100%. Now if you have these moles of it and you have the molar volume, that is 24,000, you could easily find the volume of it. Okay, volume of HI. And if you find the volume of HI, it would look something like this. You have to write the answer in the standard form: 1 2 3. So 7.68 times 10 to the power 3 should be the answer, or 7.7. Anything works. So yeah, everyone, that brings us to the end of this paper. All the best for your exam that is on tomorrow. Have a great day, everyone. See ya.